know enzymes are in nature. There are different types of protein. Like we are having primary protein, secondary protein, tertiary protein. So which kind of protein it actually has? So it is made up of tertiary. Like they have tertiary protein. They are made up of tertiary protein, but they have globular structure. They have globular structure, right? So now let's talk about properties of. So in this video, we will talk about the property of enzymes, right? So basically, first of all, let's look at. Okay, we know that in our body, various chemical reactions. We know that in our body, chemical reactions take place. Chemical reactions take place, right? So basically, these chemical reactions that occur in our body are known as metabolic reactions. These are known as metabolic reactions, and this activity and this phenomena is known as metabolism, right? And we know that there are basically two types of metabolic reactions. First, number one is anabolic chemical reaction, and number second is catabolic catabolic chemical reactions, right? Now what actually happens in these anabolic chemical reactions and catabolic chemical reaction, right? Okay, basically in anabolic chemical reaction, a product is made. For example, if I'm having a substance known as I'm having a plus B, right? A plus B. So after end, what will form the product will be A, B, right? So these type of basically chemical reactions are known as anabolic chemical reactions, right? What happens in catabolic reactions? Basically in catabolic reactions, for example, I'm having a product A, B, right? These will be broken down into A plus B. Okay, these kind of reactions are basically known as catabolic reactions. These in which a product is made known as anabolic chemical reaction, and in which a product is broken down, that is known as metabolic chemical reaction. So actually, all the chemical reactions that are like all the metabolic reactions that occur in our body are catalyzed by all metabolic reactions are catalyzed by enzymes in our body, right? So all the chemical reactions that take place in our body are catalyzed by enzymes, right? Now let's talk about the energy of. Okay, consider that. Let me energy of. Okay, consider that this is energy level, right? This is energy level. Let me write here. Okay, this is energy graph, basically, right? Now what will happen? This is energy graph. So what happens if I put a substrate over here? For example, I have placed a substrate over here. I'm having a substrate S, a substrate. And according to this graph, basically, okay, according to this graph, for example, I have placed the product over here. I placed it over here. Okay. I have placed the product over. I hope it's visible. Now, what will happen basically? We can easily understand. Okay, consider this is a substrate and this is the product. What this graph is basically showing. You can see the energy is going like this, right? It means that the energy of substrate energy is higher. Here it means substrate energy is higher, right? Um, right, the free energies are higher, but according to this, it means, according to this, the product's energy is lower. Let me write here, product energy is lower, right? It means that, for example, if you know that we have combined one reactant and the product's energy is low, it means some energy is being released. Some energy is being released, and these type of chemical reactions are known as basically known as exothermic reactions, right? As energy is being released. But what and these energy and these chemical reactions are basically known as these are known as spontaneous chemical reactions. Why? Because they don't need any energy, because you can see the energy of product is lower than the substrate, so they only need a little amount of activation energy, right? We will talk about this. So these enzymes, these spontaneous reaction means that they will happen by their own. They are happening by their own. Okay, consider that let me get a product. Okay, I'm taking here another product. Okay, this is basically product. What is this is showing, let me write it. Okay, what is this showing? According to this, product energy is high. Product's energy is high than the substrate, right? The product's energy is high. It means that some energy will be given to the reaction. So we will give some energy. Okay, this is basically the graph, and we will give some energy. We'll give some energy, right? So that the reaction may take place. So these kinds of chemical reactions are basically, let me write over here. These kind of chemical reactions are known as non-spontaneous chemical reactions. These are known as non-spontaneous chemical reactions, right? So what will happen? Enzyme will only catalyze the spontaneous chemical reactions. So what was the major point tells this is that enzyme only catalyze the, let me write over here, enzymes only catalyze catalyze spontaneous reaction. Now what actually enzymes do? Enzyme actually provide the activation energy. Provide the activation energy. Now what is that? Actually, okay, so in fact, these are spontaneous chemical reaction, right? This is the spontaneous chemical reaction. But obviously, it will require some a little amount of energy to initiate the reaction, right? This happening, but obviously it will require some amount of energy. So enzymes will not catalyze that reaction that are not occurring in nature by their own. They are not occurring, but it will only catalyze that chemical reaction that is occurring in the nature by their own self. So it just lowers the activation of energy of that reactions that occur in nature by their own self, right? So that reactions are known as spontaneous chemical reactions. Now I hope this graph is clear to you. Now let's look at the other properties. Okay, basically enzymes never change the equilibrium equilibrium of reaction. What does that mean now? Basically, for example, I'm having here 100 substrate, right? And after the reaction, for example, A80, okay, 80 products are formed. Okay, it doesn't mean that when we use enzyme, 100 substrates will be converted into 100 products. No, it will never happen, because this is against the law. We don't get 100% energy, right? So 100 substrate will never convert it into 30 products. But if you say that if we add enzyme, then 100 products, like here, we say that there are 100 substrate and we get only 80 products. It doesn't mean that after using the enzyme, we'll get 90 products. No, this will not happen. This will not happen. This will never ever happen. So what is this? This is actually equilibrium. Equilibrium means what? Equilibrium means balance. There must be balance between the substrate and the product. So actually enzyme never change the equilibrium reaction. It means, for example, this is not fixed. If there are 100 substrates, so we'll only get 80, we'll not get 90, or even though 81, not we will not get 81. So enzyme does not change the equilibrium of the reaction. Now, okay, enzyme basically enzymes that, let me erase this. So basically enzymes that perform reaction inside the cell are called endozymes. Okay, enzymes that perform reaction inside the cell known as endozyme. Okay, but enzymes which enzymes which perform enzymes which perform reactions outside the cell are called exoenzymes. These enzymes are known as exoenzymes that perform the reaction outside the cell, that are known as exozymes. So I hope the properties of enzyme is clear to you guys. And one thing that enzymes are very specific. They are specific to certain pH. They are specific to certain temperature too. We will discuss these things. Okay, so I hope this is clear to you.